Okay, so we got a couple different categories as far as what kind of things to do black holing. The first thing is obviously customer stuff. Okay, you have attacks going to customers or attacks from customers. The sources of that could be other customers, okay, or people who are off net. Okay, people that are in peer networks to you or transit networks to you that are coming to your network. You also have the people that are in control of this, right? So if you have people that are controlling these big zombie farms, and if you can find them, right, big if, then you can stop and black hole them as well. The last category we have up there is something that we've thought about for a while, and you have a couple of things of networks that you may not want to have people come on net to reach. So it's cool to have stuff inside your network, but you don't want people coming on net. So Bogons is a good one. Martian routes is a good one. Some of these infrastructure things I was talking about earlier, these voice or video gateways, if they're pieces of your infrastructure that should only be reached by people on your network, well then that's a good thing that you may want to think about black holing at your peering sites. And keep things off of your network, and that way you're only exposed to your customers, which is a potential hole. So here's some nice graphs. So here we have our backbone network. Okay, we have some backbone routers, some peering sites, and core routers. Stuff down toward the edge. We have some dedicated customers down on the bottom and in the bottom right. We have some broadband users. And you see we have a couple of representative attack sources out in the world. So of course these are all peering sites right now that are coming in. DSL user is getting hosed. Now, how you know about the DSL user having problems, I don't know. They could call. You could be actually watching your link utilizations. You see something suddenly spike up to 100%, whatever. Okay, so however you decide that this is a problem, you would go in. In this case, we're going to go into our black hole router, and we're going to inject some black hole routes into our network. And the effect of that is that we're going to be dropping packets on the peering sites. Now, what this is doing, obviously, is he can't go out off our network to get packets now. Okay? We're throwing stuff away that's destined for him. But all the services that he's using on our network are now protected. If you think about this for one of the dedicated customers, and they had maybe a whole subnet of addresses, if we're only black holing 132, then we're getting that host black holed at the peer, but all the other people on that subnet now have full access to the pipe. Okay, whereas before maybe they didn't. Now, if we're talking about from customers, now these slides can be pushed together. If not all be happening at the same time, it's just hard to look at lots of lines on the graph. So, talk about things from customers. Here we have somebody out in the world there that has a farm, maybe unknowingly. We have our broadband users who've been infected with some virus, okay, and they're slamming one of our other customers. So in this case, we're going to do the same thing. We're going to go with black hole router. We're going to inject some routes for that customer, that /32 is being attacked. In this case, we're going to be dropping them on the edge of our network. So if we think about down here at the bottom, these dedicated customers. Let's say you have a customer who has multiple sites in your network, right? Not too unrealistic. If you were to be black holing their 32 or some subnet if they're having multiple problems on all your routers, on all your edge and all your peer routers, then while that's saving them their bandwidth, they're not able to get traffic from their other sites. So if you only do it at the peering sites, now they can move on net between their sites and they're happy and they're not getting attacked from outside the world. So we've kind of built some structure, and you'll see in these slides where we have multiple discard next hops. And that signifies different things. All routers, only peer routers, only edge routers. Okay, so you can build as much stratification and complexity in here as you want to, right? But you should keep it simple if you can. All right. The last one is if you can magically and mystically find these controllers, okay, they're a really good thing to do black hole. If you inject their stuff in and you black hole in every router you got, and you don't let them into your network. Okay, how we doing? Questions? Problems? Okay, so no, not exactly. So the question had to do with certainly if we're going to be black holing stuff, we could be black holing valuable resources at the customer site. Chances are, and we can step in here if you want to. This is a customer precipitated event, so they're either going to advertise this route or they're going to call us and say, "Hey, I got a problem," I'm being DOS on this port. And so they're knowingly going to take that step, but they're going to cut off service. I don't think that right now we envision us proactively doing that for customers. We may do it for our resources, but not for customer resources. Good question. Yeah.
One quick comment in response to that is it is a trade-off. I mean, obviously you've got a situation where when you black hole it as a route, as opposed to say what I think a lot of people have traditionally done is some kind of access list, right? You can be more granular and say stop certain traffic. If you can identify a tack that's hitting them on their telnet port or something else, you can actually stop just that traffic. In this case, it's more responsive, but as you mentioned, the trade-off is that you're killing all traffic. But we have had cases where that trade-off is actually the better story, because the response can happen quicker, and in some cases where we've got downstream customers, for example, one scenario may be, hypothetically speaking, a hosting provider that's hosting a high-value target to people that are out there attacking websites. I don't know, maybe something, hypothetically speaking, like the RIAA. And so when that guy gets attacked, right, the hosting provider's pipe gets full. And if we can actually go and black hole either for him or give him the mechanisms, which we will talk about later, to allow him to actually, when he feels necessary, black hole that particular destination address, he basically opens the pipe back up for all his other hosting customers. So yeah, he's got one customer who's extremely unhappy, but he's got 20 or so customers that are happy again. It's only really a temporary solution, but it's a very responsive, very effective tool. But yeah, it does have the trade-off of you're basically just taking the guy off the air for every period of time that you're going to have that black hole active.
Okay. So let's start talking about configuration things, because that's way more cool than theory. Okay, so we're going to have two options for doing discards. We're going to have some static routes, that's option one, or this thing called the discard interface. So let's talk about static routes first. Here we have a config snippet from a Juniper router, where we have three static routes we define. So we have these three next hops, 192.0.2, 101, 103, and 105 in our case. And those will be the same next hops you see throughout the presentation, so we have nice consistency here. Like I said before, you can make more of these. You can make 5, 10, 20. Right? You can make it as complex as you want to. You can have just the one. You just have everything just wham, go to that same next hop, black hole, see you later. We've seen some value in having multiples. Yes, sir. Okay, but what's the value? So the value is you can have the only drop on the peers, drop on all the routers, only drop on the edges. So if you build those stratifications, that's what we're using these different next hops for. Okay, so good question. And of course, they'll show up in the routing table. Now, just a word of warning, caution if you're going to do this, especially if you're going to be using this to stop DOS attacks and you're talking large volumes of traffic. Reject may not be the best option, okay? Because when you do that, you're sending back ICMPs, you're talking about sending stuff up to FFP1, stuff like that. So I would recommend discard, but for sake of completeness, there are all the options. So on a similar note, right, here's the iOS output. Again, straightforward. Same set of next stops. Okay, here we're going to null 0. Okay, and again, they're in the routing table. So that is option one. You do static routes and just blast it over your entire network. Okay, all the routers get the same set of stuff. Whether you use that particular next hop or not is going to depend on the policies and route maps you're going to apply. Option two is, on the Juniper routers, we have this thing called a discard interface. Okay? It's actually an interface on the router. So you go into you do a route lookup and you're going to forward it to this interface as opposed to just doing a straight up discard or reject. You're going to have a logical unit, right? Unit 0, if you have any other interfaces. We're going to put multiple destinations there, okay, multiple IP addresses. That's going to be our next hops. What we're gaining from this is we can apply filters to this interface, okay, in an outbound direction. So now we can be doing logging, syslogging, counting, sampling. Okay, so we just do a static route with a discard, boom, packet's gone. We know it's gone, right? It's cool, it's worked, but we don't really get any visibility of what's happening there. Okay, so we're going to pull that out with this discard interface. So here's the configuration piece. This interface, so one question that keeps coming up when I preview this to people is, why do I need this destination thing? Because it's an interface, because we're putting this in the forwarding table, the router needs to think about, where am I going to send this if I'm going to send it? Now, it's not really sending it anywhere, right? It's discarding it. But because we're in that route lookup and this forwarding path decision, I need some place to technically send it to. Okay? Ordinarily, your router learns that via routing protocols, okay, or you configure something, or it gets ARPs, whatever. There's some other method it learns these next hop values and who the subnet IP address is on the far side of the link. Okay, well, here we don't have that option. Okay, so basically you just tell the router, hey, here's the, quote, next hop that you need to go to. Okay, and that's what we're using the destination command for. If you don't want to put 32s on your regular interface, that's fine. You can do whatever subnet you want. Okay, it's just we decided to keep things 1, 3, and 5, so 32 is the way to go. So you see down the bottom here, show interface output. We have the interface. We have all our possible stuff. So is this clear? We got static routes. We got discard interface. In our case, we're using 3 next hops. Okay. So that's option 1, or that's the first piece. Got to go out there and lay that down. So now the second piece we have to go out into the network and lay down is how do we find stuff? Okay, how do we do this mapping piece? The two main ways, which probably would be very intuitive if you thought about it, well, we can do things by IP addresses. Okay. Well, yeah, that's okay. It works. We can find them. We know what they are. That's not a recommendation for me because that means that Wayne comes beat me over the head because that's administratively kind of a pain in the butt. Right? You're maintaining IP address things all day long if you can avoid it. So we said, yeah, we can avoid it. Let's use communities. Okay, so we come up with a big stratification of BGP communities that we're going to use in our policy and our route maps. We're going to take the routes with the community values and assign it to next values. So obviously for things we're injecting, we're in total control. We'll add on communities like we want. We'll send them out. For things that the customer is going to send us, that'll be something we communicate to the customer. Hey, here are community 1 or 2 or 3. If you would like to blackhole your stuff on all the routers, send us a route with this community. If you want to send only on the peer routers, send us a route with the second community. We're watching stuff inbound on the network, and we'll take appropriate action. The other thing, of course, with communities is that it's pretty scalable because we're going to build the structure once, put it in place, and then we're done. We don't have to go to routers and routers and routers, updating access lists and prefix lists, things like that. When things grow beyond, I'd say 5 routers. That's kind of a pain. Okay, so just for the sake of completeness, we do have some examples using both. So here's the route filter version. Okay, so I have a policy called Blackhole by route. I find these 4 different routes, and I'm assigning the next hop of 192.0.2.101. And then I apply that to my BGP neighbors. So it should be a pretty straightforward, well-known thing for people that have done BGP for a while. Here's the iOS version again with routes. So we got an access list 88. We have routes in there. We match that in a route map and apply the same next hop. You'll see in later slides, this particular next hop 101 is what we're going to designate as all possible routers. So in this example, any of these routes will be blackholed on every possible router. So whether it comes in from a customer or a peering site, transit location, whatever, you're going to get blackholed. And of course, we have to apply it. Policies look pretty, and route maps look pretty similar for communities. Okay, so nothing really outlandish here. All we're doing is match on one community, set the same next hop. Now, if you notice the bottom, the community definition, okay, you'll see in later slides we've designated 5500 to 5599 as blackhole communities. Okay, that gives us a really wide range of stuff to be matching on, to be finding, etc. Same thing for iOS. Right? Got a community list, again, mount it in a route map, set the next hop. Now, a note on the implementation of how we're doing these regular expressions. If you notice on the 2 slides here, let me go back one. Here's the Junos, okay, 55 ... and a $sign. iOS, we got 55 ... and an underscore. Okay, that's mainly because Juniper's going to go through and it looks at each individual community value separately. iOS is using it as a string for values. Okay, so when we used the $sign, we didn't get the result we expected. Okay, so we played around with both sides, said, okay, this is how it works. No big deal, we went off from there. But just something to be aware of, you guys, when you go to implement this. Okay, so here's our structure. We're okay? Everybody, questions? So having the structure built ahead of time not only gives you the plan to move forward, but makes it much easier to troubleshoot and operate the network, okay, because you know what you're expecting ahead of time. And theoretically better security. I mean, it's only as good as who you tell. Okay, so There's going to be some pieces that you can't avoid that you're going to give to customers. That's just going to be a well-known thing. So some stratification. Like I said, we've taken all 5,500, that whole range, to be black holes. Within that, we've broken them up into groups of 10. So the first 10 we're going to use for routes that we're going to accept in from customers. Okay, so if a customer's going to send us a route that's going to be black holing stuff, their routes, it better have one of those 10 communities attached. We've also got some for things we're going to inject on the customer's behalf. Okay, so we have matching pairs. We have the customer can send us the routes. We're going to inject the routes ourselves. But we use different communities for that, because we don't want to be accepting just one broad set. It makes it harder to keep the customer out if we want to do that. Bogon routes, Martians, things like that, another general category. Provider routes, these are the services. Okay, these are your voice and video gateway, things like that. Okay, you attach those on and send them out your network and you're good to go. All right, so a couple of slides going through some examples of possible naming things, what they're doing, things like that. So customer announced black hole all, that's the 5501. We're going to set that to the 101 next hop. So again, 101 for this discussion is all possible routers on the network. And that's what it says. Then we have a customer black hole just in the peering sites. Okay, and that's 5503. So this is the, hey, I know, or they've called and we've been able to figure out that the attack's coming from off-net. Okay, so we tell them, hey, send us this route, or they figure it out and they send us this route. And we're going to block this in the peering site. So on-net traffic is still good. Okay, so site-to-site stuff within your network, still okay. Peering sites are what you're shutting down. So not surprisingly, we have the same structure for routes that we're going to inject. So 5521, 5523, okay, match up the same set of next hops, same set of instructions. We've actually built some more stratification in this scenario. And instead of just dropping on the edge or on the peering sites, you drop on the core. So you can come up one level from the network edge. A couple of reasons maybe you want to do that. You could have, let's see, a desire to have stuff cranking away, doing maybe hairpin turns inside just this pop area and not the rest of the network. That's one option. Could be another option that you have different monitoring and stat collecting capabilities on your different sets of routers. Okay. For whatever reason you want to do it, that is an option, and that's where our third next hop comes in. Okay, so for this discussion, we have 101's all, 103 is peers, pardon me, and 105 is on our core layer. Okay. All right, so next grouping of stuff, we have Martians. Okay, that's 30. We've got the RFC 1918 addresses, it's 31. Notice these are all going to all routers. Okay. Things that we've designated as never see anywhere, just trash them. One of the possible advantages of doing this is you could, depending on how you want to lay stuff out, we'll probably end up in a mix of both, is get rid of some of your filters and parts of your network. Okay, where you're maintaining these huge access lists or route filters for all the reserved addresses or all the bogon space, things like that. If you're doing this from one central spot or multiple central spots, and you have a more automated way to do it, then it avoids you having to go and touch all the routers on your peers and edge of the network and update stuff. So reserved addresses. The public exchange, these are spots, public peering points, places you're not at. Because if you're at there, well, you don't want to be blackballing that, right? You could, but that's not really why. So places you're not at, you want to blackhole that stuff. Okay, so now infrastructure things. Here we have peering links. Okay, 5540, again in all routers. And this you kind of have to be somewhat careful of how you're doing that, but we've seen some value, or we think we're going to see some value in helping control who can and cannot get to some of the peering links in the network. Okay, because you don't necessarily need everybody to be able to go there and ping and do certain things on those links. So we'll see how that goes in the future. But for now, it's in the plan. LAN things. Okay, so this might be a good example of your DNS, radius servers, management networks, things like that. It should only be accessed by people on your network. Well, radius for sure, unless you have some other peering agreements, right? So you can get complex and have to take in other things into account. But let's just play simpleton for a while and pretend everybody's on your network, and that's the only way to ever connect. And you need people off net to get to those services. Okay. Questions on any of that stuff thus far? Is this making sense? Okay. It's after lunch. Okay, so let's talk about multi-hop for a second. On the edges of our network, where we're going to be talking to people using BGP, if we're going to be accepting in routes from this customer, and we're blackholing stuff on that edge, we've got to turn on multi-hop. The reason is, quite simply, by default, the next hop's got to match that peer. And the way to get around that restriction is to turn on multi-hop, because then it lets you do a recursive lookup. If you don't do this, pretty easy to see. On a Juniper router, it's going to be a hidden route. Okay? On a Cisco router, you initially install a route, but as soon as you run through your scanner, it basically makes it inactive. Inactive? Inaccessible. Okay? Which means it don't work so well. Okay? So you got to turn on multi-hop, only if you want it to work. So here's some obligatory config snippets. In Junos, we're just going to configure multi-hop within the peering session. Down at the bottom, get EBGP multi-hop. The 2 in the bottom examples for TTL restriction. I didn't add that in the top. You can if you'd like to. By default, it's going to go out just for the 1. But if you need to ensure that it's going to go multiple hops, you can do that. Okay. Now, we've gotten our discard things installed in the network. We've gotten all of our policies on route maps applied to the network. Okay, so now we've laid the infrastructure for being able to take routes and actually do the backhauling. And we're going to do that either from the Blackhole router, the way we inject it, or we're going to accept it in from customers. And Wayne's going to talk through some slides.
Okay, as Joe mentioned, we're going to continue the discussion now, actually talking about how we're going to configure the Blackhole router. If you remember the diagram earlier, with this little black square signifying our Blackhole router, we're going to inject it there. And as we mentioned earlier, too, we also didn't cover every config snippet. There's a couple things here that I don't think we specifically cover, but there's things like the fact that in the diagram it's sort of implied, but it's iBGP with the rest of the backbone, no IGP for, I think, obvious reasons. But we're going to cover a couple of the policies, et cetera, for the Blackhole route and actually injecting information into it. Fighting off a bit of a cold, so I'm going to do my best here. Bogon routes. Now, we can manually inject the Bogon routes the same way we would, say, other customer network routes or host routes, etc. And we can break it down as we just went through the stratification that could be used to actually break it down into Martians, RFC 1918, and INA reserve. Now, in one hand, you might say, well, why bother? And in fact, depending on who you're talking about, it's semantics, right? As people say Bogons, they mean all 3 of these. Some people say Bogons, they mean just INA reserve. In fact, I think, though, if you're looking at other sources out there, like the RADB objects that are maintained out there, the Bogons actually apply to all 3 of these, but they are actually broken out into Martians, RC-19, and INA reserve. And one advantage of actually breaking it out like that, if you think about it, the only thing that really, as far as I know, should be changing is INA reserve. Right? The others should be static. So, in a sense, from a dynamic standpoint, the thing you're managing is really the INA reserve. So you can actually keep that all internal, do it all manually yourself, whether it manually means you're actually updating the list on a route server, or what I think a lot of people are doing, are familiar with anybody familiar with the external Bogon route server that's out there? Anybody actually taking feeds from it today? There's actually, from the same places a lot of people get that information, NANOG and other mailing lists, you can actually see when INA actually takes a block and allocates it to a registry. And at that point, you need to actually take that out of your filters. This is actually something that can be operationally intensive. I mean, we've actually had cases where, if we're doing it manually, it's difficult to go through and update that in a timely fashion. We actually were one of the ones who received one of the new blocks, so for a period of time that we were actually filtering some of our own customers. Obviously not a good thing. So to automate that is obviously a big plus, and you can take that feed and let them actually update your knowledge of what is currently INA reserved and what's not. Now, usually when you start talking about taking an external feed from somebody straight into your Blackhole router, turning around and propagating that out to your network to drop it, that usually raises the hair on the back of a lot of people's neck. So we're going to talk a little bit about some reasons why you can be confident that's, or steps, I guess I should say, you could take that should make everybody a little more comfortable with that concept. So The other thing we're going to talk about is host routes. This is the case where we have a need to black hole either customers because maybe they're not a BGP speaking customer, they don't have the ability to do it themselves, or we've got a case where we've identified something from an operations standpoint and you want to go in and black hole their address for them until they clean up whatever they need to clean up. And here again, this actually applies probably to all the routes you have on your black hole router, but most definitely for your customer black hole routes, you want to have a tracking mechanism. We mentioned in the introduction, methods to integrate this with your network management systems, but at the very least, trouble ticketing, something else, you have a way of tracking, why is this black hole here? A lot of times you go through a router configure, something like that, you can try to figure out, where does ACL come from? Why is it here? Or you go to customer interface, if you used to do that to respond to DDoS attacks. You see this ACL in there, maybe it's not getting any matches, it looks very complex and you have no idea how long it's been there or if it's still needed. So from the standpoint of injecting these routes on a black hole router, it'd be very helpful to have a way to track that, find out if it's still required, which goes to the next bullet there, audit procedures. You definitely want to have a way to actually answer that question. Why is it there? Is it still required? And this is especially important for your dynamic pools. Some networks have more dynamic pools than others. Some are maybe completely static. I don't know, but you definitely, from a dynamic standpoint, you want to keep those pools fresh. You don't want an instant customer actually connecting and getting the old botnet IP address, or some other customer's doing something fishy, they got black hole, and you have a stale static route in there that's now actually keeping him from doing anything on the net. So to those ends, we have a couple examples here. Have a couple policies here. A lot of this is just perhaps a little verbose, but it's just going through the various groups that that Joe previously defined, where we're getting into the various categories of announcing the black hole all, identifying community. Looks like okay, it's customer in black. So black hole all, we talked about actually sending to all the routers. In the example we've been talking about here, this would be prepended with whatever your AS is, and then as an example 5521, and that's how we propagate the customer all, and then we go to define the rest of them. There's the usual. Yep, yeah. Talk about actually the stratification, actually breaking it down, Martian, RC1918, INA reserve, and then the rest of the categories that we get propagated out. So on the black hole router, we want to actually define those community lists, so in our route maps we can set them. And here again, for completeness, we've got both the Juno's policy language as well as just a expanded community list in iOS, doing effectively the same thing. So then also the prefix lists, basically going through here and actually statically defining these different categories. So we're showing here, the Bogon Martian list, 1918. The one I don't have up there because it's rather lengthy is the INA reserve. Now this is where I was going to take a bit of a sidebar. This isn't really shown too explicitly in the presentation, but just to talk a minute about the building the confidence level, I guess, at accepting an external feed, BGP feed, to help manage your Bogons. By taking a snapshot, it doesn't really matter when you do it. Whenever you configure this, if you just go in and take a snapshot of whatever the INA reserve space is, build a prefix list saying this is today whatever the INA reserve spaces are. And when you build your route map to this external server, right, you're going to take a BGP feed from this external server, and you build a route map that's actually matching on a prefix list to match the Martians, the 1918, setting the appropriate community, which we'll show here in a minute. When you do that for INA reserve, by taking a snapshot and just defining what that prefix list is manually, the beauty of doing that is that you are ensuring that you are only taking the Bogon space from that external server. So, because the first concern that anybody's going to raise is, whoa, external BGP feed feeding right into our black hole router. What happens if X, Y, and Z happen? And that's usually X, Y, and Z is some scenario of the service getting compromised, announcing your own space to use, so you black hole your own customers or whatever. By doing this and statically defining it, you protect yourself, so you're only getting the prefixes you expect. You can also, since you're breaking it out, if you have the need to, you setting an appropriate community for each type of bogon. But since the only thing that's going to happen to those INA reserves is they're going to actually remove them as they get allocated to registries, that list will only get smaller. So, I mean, because in one argument you say if you build a prefix list, well, you just took away the whole automated nature of it. Well, not really. You take a one-time snapshot, build a static prefix list. At that point, you've defined what all they could be. The list is only going to get less. So you do it once and you're done. And then after that, as they allocate the blocks and they get removed, you're still protected, and it's still automatically updating all your filters in your network so that you're filtering the correct bogons. Since I wasn't really up on the slide, did that kind of make sense? I hope I kind of walked through that. You can kind of see the value there. It becomes quite helpful, and it also, like I said, helps provide confidence that even though you've got an extra on PGP speed, it's still okay. So here again, this is another example of the prefix list, finding out what they are. For those that I guess don't know really the differences, it might be helpful with an example there. But these are all defined, like I said, there's actually RADB objects maintained if that's a method you're using to gather the information. So some examples of the policies actually on the Blackhole router that you could set up would be to advertise a policy statement called advertise bogon routes. This is where you would be actually doing just what I said earlier, where you're accepting, the term margin. You're actually looking for your prefix list where you define what those margins are, setting your appropriate community for that type of route. It gets propagated out to all your routers in your network. As previously discussed, those policies then match that community and drop them appropriately. Same thing for the 1918, and of course the INA reserve is not on here, it's too lengthy, or actually just more of the same, really, in this case. So, and then this iOS version of the policy down at the bottom, where you're just simply matching on the prefix list you define, setting the community. The other thing to discuss briefly, and this isn't so much, I guess, configuration on the Blackhole router per se, but for lack of, I guess, a better place to insert it, really, they're talking about accepting customer routes for Blackhole. And since we're not going to actually, well, we could, like I said, in these cases where they're not a BGP customer, we could go in there, enter the static route on behalf of the customer to actually Blackhole space in response to whatever attack he may be experiencing. But we may also want to allow the customers, BGP-speaking customers, the ability to actually do this for themselves. You may or may not already have the EBGP multi-hop set up, which is something Joe covered earlier. So this is one place where I think people may have first run into this, is when they went to go turn on the customer edge Blackhole routing. They discovered, actually you might need multi-hop on that case. It may not have been as obvious internal to your infrastructure, unless you're doing something like using private ASs perhaps to segregate services out. Maybe all your DSL or broadband services you may, for whatever reason, have them actually on a separate AS. Other telcos may have run into the GSP model. I don't know how much that means to anybody in here, but there was a time in day and age when telcos actually, because of regulatory issues, actually had their networks actually configured in these multiple different ASNs. And so when you then move to a common backbone, you're actually feel like a company that just like sucked up many different networks. And you've got to deal with the fact that some of your connections are EBGP. So there is the case of one, making sure your policy includes EBGP multi-hop. But this is definitely going to be the case for your customers. So the idea here is actually to set up a policy to give the customer this autonomy, basically control his own destiny, so to speak. But you also want to protect your customers from each other. So first and foremost, the thing you want to do is, of course, going to be to keep the customer from blackholing other people's routes. And the way you do that typically is you just have a prefix list inbound to match on whatever he has already agreed to announce to you. And in many cases, best practices, most providers more than likely are actually already doing that. The one thing they may not perhaps be doing is, depending on what your aggregation rules are, you may have prefix lists in place that are actually only accepting his major routes. So, if the customer's got a /20 sign, you may have the prefix list statically signed to only allow the /20. But for purposes of a customer that's perhaps connected to you in multiple places, may want to influence a little traffic engineering or something like that, may be announcing longer prefixes, you may actually have that range set up to allow maybe the /20 up to 24. I don't know. But here in a minute, we'll just talk to the fact that, and I guess it's the next bullet there, you actually want to allow the range of subnet mask lengths and probably the whole range. In other words, build a prefix list so it allows up to a 32. The reason being, obviously, you want the customer to be able to announce host addresses to be Blackhole as opposed to network subnets. And what he's going to be doing, obviously, on the policies, the rest of the policy is going to be to actually match on a known community. That's going to be his mechanism for actually communicating that information. I think that was also already covered in the example communities, where you go ahead and reserve a range of communities he can use. And when he sends you that community on a route, you're going to actually then take that and propagate it out to the rest of the network to actually Blackhole. Although, like I said, depending on your stratification there, you can give him the ability to say, hey, I want to do this everywhere. Just get this traffic, off, away from me. And if he sends it to you with the customer routes all routers, you're going to actually put on a community and drop it everywhere, edge, peer, everywhere. Or, especially in the case, as Joe I think previously mentioned, if he's going to have a multi-connected network, or he's connected to you in multiple places, he has the ability to actually say, just get this, stop it at the piers. Allow me to communicate, my company to communicate between, say, corporate and remote sites, etc. But if I can stop this traffic, which appears to be coming from external, then he can actually have the control to actually say, only do it with the peer routers and send you the appropriate community. And of course, you've got the mechanisms already built into your router, not only your edge routers, but also the Blackhole router. But really, the policy there needs to be in place actually at all throughout the rest of the network, right? Because the router that's going to be getting this is going to be the customer edge router. One other quick comment I just thought of, I meant to cover earlier when we were talking about the bogons, the prefixes, and taking that external feed. If I can actually just go back, I did want to cover this. This is as good as any. For the 1918 space, especially, if you keep taking this 1918 space as part of your bogons coming from that external server, I mean, it's pretty much just defined, per the RFC, right? So on a /16, /8, whatever, which is great for carrying that internally, right? And so you take away your filters. You may already have filters in place today that would prevent any kind of announcement, that's announcing 1918 space. If you want to propagate this information internally, you're going to need to, of course, remove those filters internally so that these route propagations can actually take place through the Blackhole router. So the Blackhole router is now in charge of sending these out and keeping everybody up to date on what not to route for, what to drop packets for. One thing you want to keep in mind, though, when you do that is more than likely you're still going to want to keep all your existing prefix lists or whatever policy you have in place at the edge of your network, whether that be the customer edge or the peering edge. Because if for whatever reason somebody upstream from you, heaven forbid, makes a mistake, somehow allows a 1918 prefix to come in, or probably more likely a customer somehow messes up and advertises, say, a 192 or say a 10 network address as a /24, that's going to go in, right? Because if you remove the policy that prevents the 10 address prefix from being advertised in your network, he gets it in. You may have an address, or excuse me, a route table entry for 10/8 space. But of course, long as match rule wins, he gets that 10 address /24 into your network, may cause you difficulty. So this is great, definitely, for taking that feed and handling it internally, basically for your core infrastructure. But keep that in mind. You probably want to keep whatever existing policies you have in place at your peering edge or at your customer edge in place, because you really don't have any way of controlling. You won't have to have a route in there for every possible route, of course. So, sorry for the slight digression, but I do want to cover that. That's what I thought. Wait, customer doing here, and then an example of what the policy may look like. So, on your edge router, you've got policies in place to, first of all, identify the community list you're looking for. You also have the basically the policy at the edge here, where you're looking. This would be implied inbound on the customer's BGP session. So you'd be looking for the customer announcing the community on whatever route. You've also modified, if necessary, his prefix list for his announcements he's sending to you to allow actually up to 32, so he can send you those host routes. So, provided he sends you the right route within the right range, he gives you the right community, you're going to then set the next hop appropriately, basically discard disappears, and that information will then propagate through the network, and you'll start dropping that attack traffic or whatever it is, whatever that traffic is destined to that customer at the peers. Any questions so far? So the end result. So here is an example output from a router that may be configured with some of the policies we've described so far, using some of the same communities. As mentioned earlier too, obviously a lot of this example output may have been hacked, so some of it may have not looked completely legit, but the address has been changed to protect the guilty. So you have a given /32 that shows up in the routing table that has actually been propagated from the Blackhole router that has obviously had his next hop set here because he actually matches a community down here, which is the instruction for the router to say, hey, when I see routes coming in with that community, I'm then taking the appropriate action, setting the next hop to actually discard it. One other idea that might be good is to have some semblance of a community. We didn't really discuss this one. A kill community, like for your peers. This may be just an additional safeguard if you are propagating these routes from your Blackhole router and you are you want to make sure that none of the stuff you're propagating, especially if it's like the 10 address space or any other kind of bad prefixes, you can actually take an additional step to add the community, which is a kill community at your peers. This is important, especially, like I said, if you're having to deal with the scenario where you've got multiple ASs in your actual network. You can't use a no export, right? Because the whole idea is you want to propagate this through your whole network. You've got to get it across AS boundaries in your network. So you can't tag the route, like I think in some cases there have been some recommendations, and just tag it with no export, which is certainly an option if you're just a single AS. But if you, like I said, have multiple ASs in your network, the way around that is obviously just to come up with your own kill community so that you can be extra nice to your peers and be doubly sure that you're not going to propagate any trash out to them. Let's see, anything else on that slide? So one other use for this that I think has been covered in some other forms, but one that I think there's probably some debate on whether or not I guess how useful it is. So take it for what it's worth, but it's kind of an interesting application of this, where you can actually use the same mechanisms, the blackholing information, to actually drop based on source, right? So far we've been talking all about dropping packets based on destination address, right? So when packet comes in destined to a given address, when it looks it up in the routing table, he says, oh, fill it to 0, and you kill it. But you can also actually use this same mechanism to drop traffic based on source address. So if you're getting packets coming in your network that are sourced from, I don't know, Bogon space or other traffic that you've chosen with Blackhole, those routes are actually in the route table. But what happens is, relying on the unicast RPF or IP verified source or whatever your vendor's terminology is for basically verifying that when the packet is received on a given interface, checking the source address, it then looks in the route table and says, what route, when I look up a route to that source address, would I send it back out the same interface? If yes, accept. If not, discard, right? That's the whole idea of the unicast RPF check. So the next step would then be to have the logic of the router treat a Blackhole route or a route lookup to 0 to be invalid. The same thing, yeah, I wouldn't send it out that interface, or no, I don't have a route. So when you actually propagate the Blackhole routes out there to your infrastructure, and then you have on your interfaces actually upstream to your core, have the RPF check turned on, as shown here. In the interface, you get the IP verify unicast reverse path. It's then going to attempt to do a lookup on the source. So one way to see this, and also if you're configuring to check to see what's happening, you can actually do debug IPsec drop verify. Although this keyword right here, I think is iOS dependent. I think in the middle of doing this change iOS version, I think it might have been in some cases RPF. So it's some iteration of that, RPF or verify or something, that should hopefully be relatively obvious. But you create that debug command, and you'll actually be able to see, in this case, packets were coming into a valid address, but they were sourced from 127.0.0.1. Since the Blackhole router was actually propagating that prefix as a Blackhole route, i.e. to null 0, it's actually failing the RPF check. So, like I said, you were actually using the Blackhole mechanism to actually drop based on source address. Any questions on that time? Anybody using this by any chance? It's generally something bogus. I mean, I think when we first started looking at some of this, there were some questions as to whether or not, you know, what, and this is what I was kind of alluding to, what the value would be in actually turning this on, depending on how much filtering you have in the rest of your network, right? You know, depending on how much you deploy unicast RPF at your edge for your customers, right? Then no customer, if you got unicast RPF turned on for your edge, none of your customers could be sending that traffic, right? Because obviously they're not going to get that through the initial RPF check. If you've got various filters at your peering edge that don't allow any traffic sourced from that, then the traffic wouldn't get in there anyway. But without starting a whole another NANOG-ish thread on, you know, whether or not it is or is not difficult to do this on multi-home customers, if you have, for whatever reason, chosen not to do that for that reason, that may be a hole, right? That may be a hole where your dedicated internet access customers, your BGP customers, whatever, may not have that turned on. And, I mean, they're just as vulnerable as the next guy, right? I mean, they have machines that may be owned, may have something on it that's actually spewing this kind of trash out there. And this would be one way, so inside your network, to protect yourself. So you've got this whole, you got your peering edge and your customer edge, maybe your, you know, broadband type customer edge, but you sort of have this middle area where other dedicated customers could actually be spewing people on your network, and this would be one way to get it off. And also, since you're doing this on, here again, the Blackhole router basis, it's dynamic, right? It updates automatically. So if somebody was spewing from something not as obvious as that space, but it's, say, INA reserve space, then you would obviously be keeping your unicast RPF checks up to date because it's all Blackhole instead of ACL based. So, I saw another comment or question. Did somebody do something else? Okay, so now we've moved well into this discussion to talk about what the discard options are. We talked about how we go out to all the routers on our network, map those routes to Blackhole communities, take appropriate action. We talked about injecting and accepting them. So we're up and live, we're running. Now we've got to talk about what kind of data is this providing us, how we track and what we're blackholing, those kinds of things. So to see what's being blackholed, you can obviously look at the route table. That's pretty obvious. If you know your next hops, you can just look at the route table, see what's going to your Blackhole destinations. But you can also use some other methods to help you, count how many packets are being blackholed. Maybe look at some packet headers, get some other intelligence from the traffic that's actually being blackholed. And some of those methods are things such as outbound filters. You can actually apply an outbound filter on your discard interface so that you can actually count the packets. Actually do anything you can with a firewall filter. Logging, syslog. I'll leave it to Joe to actually talk about those in detail, especially any potential performance impacts you may get from doing that. But if it's configured correctly, you can correct me if I'm wrong. If you do that correctly, and your destination address is all correctly, it's in forwarding logic. You really shouldn't take too much of a hit, I think, turning that on. But you can certainly get a lot of information right off the router if you are limited to only that source information, as opposed to, say, offloading the attack traffic to some kind of sinkhole analysis language or something like that, which is something else that's a little out of scope of what we're talking about today. But and of course, you also have sampling, where you can basically get flow type data, which may be enough to help characterize the attack and see if you can perhaps take other action. So taking a look here at some sample flow output, this also shows potentially the value of having multiple next hop IPs. Joe showed the value on the Juniper router of having the multiple discard interfaces. Cisco only has the concept of the one null zero interface, but with using multiple next hop IPs, you still can potentially glean some information by having that granular level configured, because it actually will show up in your flow data. As you can see here, in this case, when we look at the flow data, we actually see that, yeah, the destination interface is null zero, but we can actually pick up the destination IP. So if you want to glean information based on destination IP, in your pipe include, pull out certain kinds of information from your flow data. You can pick and choose what kind of traffic you're looking for based on IP address, destination IP address. And also you get all the typical net flow information as well. And you could also be, of course, exporting all this flow data to some other external system, Arbor or something else that's helping you track attacks and what's going on. And to finish discussing the discard interface stuff, I'm going to turn it back over to Joe, provided there's no other questions for me.
Okay, so here's what I'm calling a simple filter, mainly from the perspective of we have the discard interface, we have multiple destinations, which is cool, but because it's a singular interface, we get a singular spot to apply a filter. Okay, you get one, and that's it. Who knows? Excuse me. So on the bottom down here is the definition of my filter. I don't have any match criteria. Okay, so all possible things getting forwarded to the discard interface, regardless of next hop, are going to be incrementing, that one counter, being sampled and then being discarded. Okay. So that's cool, but it doesn't give you a lot of visibility. Okay, because of the singular nature of the filter and the one counter I had, that's it. Things are being black holed. Yahoo. To take this a step further requires a little bit more effort, a little bit more configuration pieces, but gives you a lot more visibility. What we're going to be doing is using destination class usage, or DCU. So what this is you're going to have a policy that you're going to apply to your forwarding table that's going to match your BGP communities for black holes to a destination class that you define. What that allows you to do then in your filter is have a match criteria on that destination class and then have some actions. Okay? So the end result is we're going to have individual counters, per destination class. So every individual community you have defined, you now have a separate counter for it. So now I can see how many packets are being discarded due to the customer black hole all, or how many are being discarded due to the infrastructure or peering links. And I gain that kind of level of visibility. So here is my policy. Okay, it's very straightforward. From community X, then destination class. Okay, I've chosen to name things kind of similarly because you saw our list already. We already had 12 communities defined, and if it grows any further, then it just kind of gets out of hand after a while. But you define your policy, apply it to the forwarding table as an export. That's part one. That actually does the mapping of community to the destination class. Part two is in your filter, you now expand it to have multiple terms. Okay, from destination class, black hole all, DCU in this case. Then increment the counter called black hole count. Okay, so now I have per counters on a per DCU basis. And again, I'm doing my sample and discard. So now I have the visibility on a per next hop, per community basis, how many packets I'm doing, and you can see that, you do a show firewall filter, filter name, black hole router in this case. And my two counters, in reality, I'd have a whole list of counters. So, first off, we very much welcome feedback. Like I said, it's already been through a couple of peers we have out there. If you have stuff, feel free now or in the future, send us an email, whatever. We're happy to take whatever you got and kind of keep it growing. Questions? Can I go back 2 slides? 1, 2, check. Yeah, they just asked me to go back 2 slides. One more. Anything in particular, or just check it out? Okay. Anything else? Yes, sir. Yes. I'll let Wayne take that one. The question was, how often are we actually doing this on a day-to-day basis?
Trying to figure out how to respond to that. As you can imagine, to get up present on this kind of thing took some approval. This was kind of be representative only. I don't know if I can actually respond to that, to be quite honest. I mean, I'm sure if anybody's out there responding to DOS attacks, you know that, I mean, there's basically daily occurrence of this kind of traffic, and the need to do it is on a daily or more basis. So, you know, any tool that you can deploy that allows you to respond faster is going to be of great benefit. So, I hope that wasn't completely useless, but I don't know if I can really get into the details of that too much. Sorry. Anybody else? The question was, what has been the average response time? That would depend, I guess, on the method at which we received the request, or determine the need to black hole. So, I mean, it's just, I mean, as far as propagation, I mean, as soon as you make that decision, it's you know, on average like 5 minutes. I mean, as soon as it propagates, you know, and you install the route, it's pretty darn fast. So, and it also depends on the nature of the attack. In some cases, you know, if you're blackballing a customer /32 route, you know, the effect of the relief is almost instantaneous. If you're attempting to be part of the greater good and help destroy a botnet, it's often unclear, really, as to how much effect you may or may not have had. Just out of curiosity, I think I asked this once before. I'm just curious. I only saw a couple hands, maybe shy to answer, but how many people actually deployed actual black hole? I know of at least 2 people in here who have that are doing it various ways. Just out of curiosity, anybody care to comment on their platform for what they're using as a black hole router, what they're using to actually inject their routes? I mean, you can do it everything from, say, a 7206 or 2600, or it doesn't take much really, but preferably something a little reliable. And if it's not that reliable, perhaps a redundant router in a different location. Because of course, remember, as soon as your router blows up, all your announcements go away, and you know, everything's flying in the clear. Okay, the question is what's the take rate or the acceptance rate of, or the demand for the capability to do the customer edge black holing? And I would say it's relatively great. I mean, because almost any time you get a request for an ACL to block an attack, you can pretty much equate that to, you know, the need to do the customer edge filtering. So, and anytime you can put the customer in charge of that, because one of the biggest frustrations, of course, they have is they'll complain about how long it took to get, you know, a hold of somebody with clue, you know, in order to put in the right ACL, as opposed to, you know, something like deny IP NANOG or something. Yeah. Problem solved. So, yeah, I know I see somebody in the door. I think he's doing a lot of this already. So. Okay, so the question, if I heard it all correctly, is what precautions do we take to make sure that the black hole router is not abused? Is that a good summary, or? Okay, the question again, I guess, is how do you protect the black hole router from doing something like black holing your own DNS infrastructure? And I assume you mean by somebody external to your operations staff who didn't make a mistake. You're talking about somebody who's intentionally trying to do this. Well, in order to, well, first of all, the black hole router, one thing we didn't really cover up here is that the policies on the router are such that you don't accept routes in the black hole router from anybody. Except for potentially routes you're accepting from an external Bogon route server, and then you statically define exactly what route you're going to take, and you don't even accept routes from your own internal infrastructure, right? There's no need to. There's no need to accept any routes in from your infrastructure. So there's really no way to inject a route into the black hole router other than to actually be on the router, compromise the router itself, enter a static route with the right mechanisms, right, to get it to inject, or, as the other scenario I mentioned, to compromise the external, like bogon route server, which, granted, may be a lot begging for the buck, right? Because if you can do that, you're going to get everybody who's using the system. But like I said, hopefully, people have taken their own precautions, like I mentioned, so that the bogon route server is not capable of sending you anything. Or let me rephrase that. You are not accepting anything from the bogon route server other than what you explicitly say you want. And like I said, because that list is static, it's only decreasing. The value of it is that the routes are only being removed as the INA reserve blocks get allocated. So you take your one-time shot, say, this is all I'm going to accept from that guy, and that's it. And you're effectively protected, but also getting the benefit too. So I think that covers everything I can think of. Does that answer your question?
I guess we're concerned about. Right. So things on the end, right? Your inbound route master policies only allowing routes from their allocated space. Okay, so they shouldn't be able to send you a route that matches your DNS server if that policy is put in place correctly. Okay, and in addition, it also restricts what communities they can send. Okay, so you try to lock them in as best you can so that they can only harm themselves. Right. Yeah. Okay. Okay, so the question had to do with we're injecting routes for a customer. The customer is not the end state, the end network. They're actually a transit network for somebody else. Okay, so we're concerned about we're black holing stuff that only gets to the edge of our network. Okay. And not re-advertise, in other words. Is that what you're saying? Okay. Yeah. Okay. So so that would be a policy. So you'd have an inbound policy to accept the black hole stuff, and do scrubbing or taking some action on the outbound side to remove those. And conversely, while I'm thinking about that on peering sites, this kind of goes back to what you were saying. You would have policies that wouldn't accept routes with any of the black hole communities that you know of that you've defined. Okay. So that would keep things coming in from peering and transit sites from doing that, what you're afraid of customers doing. Now, yes, follow up. Right. Yes. Yeah. Because I mean, you're using the route mapper policy, and all the tools that are available to that are available to you here. Does that make sense? Okay. Yeah. I don't think that we have had any discussion with anybody else about being cooperative in this regard. Yes, sir. Okay. Pass between themselves?
Chris Morrow from the unit in the back.
Yes. Sorry. Okay, so it has to do with configuring static route and putting reject on it. The reason I'm not going to do that for myself is that generates a lot of internal traffic on my router and is harmful to me, regardless of what it does to somebody else with sending back those ICMP unreachables. Oh, I wouldn't. It was just there to say, hey, keep this in mind, okay? Because a lot of people, get confused with the start of it. Yeah. I would say no.
I don't think so, and I don't know if there's I think a iteration of that. The question was, if the customer got a /20 sign and he's only using a /24 out of it, should he announce the /20 to you with the Blackhole community? To me, I would actually, if I understand the scenario you're describing, I'd almost characterize that as passing the buck, in the sense of, you should do your own bit bucket routing from the standpoint, right? That's best practice, right? I mean, you should have your own null zero so that if you're not using it, it's your block. Let it come in and throw it away. I think it would probably be somewhat dangerous, I guess, to do it. Okay. So, okay, did everybody hear that? I think what Chris was saying was actually passing the garbage collection off to your bigger pipe backbone, if I'm characterizing that correctly, right? So that basically the customer is announcing, as he described, his larger block with the Blackhole community, so that for the stuff that's scanning unused space that's within the customer's block, it's effectively getting thrown away. And so for the blocks that the customer actually is using, the more specific route is being propagated up into the backbone and it's being correctly routed down to the customer. So the customer isn't actually having to haul that garbage through his pipes, that's scanning traffic, whatever it may be. Anything else? The question is, do we have any experience integrating this with an IGP across an enterprise? Not specifically. No. I think there may be some out there that perhaps in one of the Virgin Feathers or something like that, you might find somebody willing to talk to you about that, but not specifically. We don't have a need to do that. In fact, we specifically want to keep anything like that separated. So. Well, all right. Anything else? We'll be up front if you want to come chat with us offline about anything. So thanks.